everyone. I, Kyan Vanara, welcome our dear principal, Mrs. Revati Srinivasan, our vice principals, heads, coordinators, grandparents, parents, and my dear Solonians to the virtual Anweshan 2020. As it is rightly said by Jonna Leary, that every brilliant experiment, like every great work of art, starts with an act of imagination. Science is the elixir of life, and Anweshan is one such platform where students get to share their ideas and collectively galvanize them to bring something innovative into implementation. Science, embedded with creativity, has always played a vital role in enhancing students and to provoke them to innovate new projects. These budding scientists may later be trained as proficient inventors for the growth of the society, nation, and humanity. So let us unveil the miracles of science through the innovative inventions of the Solonians.
Hi, I'm Gautam Naik from 6A and the title of my experiment is How does paper run away from washing gel? Sounds like magic, but it is really science. So what do we need? Let's see. Some water, a small bowl, some washing gel and some paper powder. First, we have to pour some water in the small bowl. Then, sprinkle a few pinches of pepper powder on it. Then, take a drop of washing gel on our fingers and dip it in the bowl. And we see that the pepper has moved away from the gel. How? Attraction of molecules forming a surface film holding the water is called surface tension, which makes the paper float. Washing gel acts as surfactant and therefore reduces surface tension of water. So, surface film of water starts dispersing in all directions and carries the paper along with it. Thank you.
Anweshan from 6A, and I am going to present an experiment known as smoke waterfall. For the experiment, you will be needing a glass of water, a paper, a fork, and a matchbox. First, take the paper and fold it in a form of a tube. Then, place it between the two spikes of the fork. Then keep it on this and lift this part of the paper. After a few minutes, the smoke will come in the form of a waterfall. See, the smoke is coming down and it is forming a layer on the bottom. Hot smoke is lighter than air. That's why it goes upwards. But in this case, the tube gives the smoke time to cool down, and cold smoke is heavier than air. That's why it goes down and forms a layer on the water. Thank you.
Hello to respected teachers and dear friends. I am Priya Dildar from class 6A. I have tried to make an insect repellent liquid. Available item I want to share with you all. The materials required for it are ginger powder, garlic powder, and clove powder 2 teaspoons each and half cup water to mix them all. So now let's start the procedure. First, we have to mix all these powders in the water. Then we have to stir it for 5 to 10 minutes to make it dissolved. Now we have to just filter it. Now it is ready to use. The solution is brownish in color. This is a solution of the material. You can use it by spraying in the corners of the rooms where insects come. A request to you to try this experiment. Stay home, stay safe.
Hello, I'm Atharva Bagde from Standard 6A, and today I'm going to show you my science Anweshan project. My mobile fan with light. I've named it like that because we can carry this wherever as we want like a mobile. Now I will show you how it works. Now I will tell you what material I've used to make it. I've used a fan, a motor, a cardboard piece, a light, a battery holder, a switch, a cardboard box and some wires to connect them. Now I will tell you what is its benefit. Its benefit is that it works on battery, so electricity is saved. And its use is that we can use it in the day as well as in the night. In the day, I can use my fan to take air in the hot summer. And in the night, when my electricity is gone and there is dark, I can use my light to see in the darkness. Thank you.
Good morning, ma'am. My name is Rashi and today I am here to show you science experiment on the topic of air occupied space. So first we need to pour some baking soda in this balloon. Now we have to pour some vinegar in this bottle. Now we have to tie this balloon on this bottle. Now we have to slightly straighten the balloon so that the baking powder mixes with the vinegar, and as you can see, the chemical reaction is producing the gas. This was my experiment and thus it proves that the air occupies space.
Respected all, I, Ansarda from class 6th A, thank my principal ma'am and all the teachers who have given me this opportunity for doing this experiment. My experiment name is DNA extraction for banana. For this experiment, we need a bag, bananas, warm water, salt, cold alcohol and liquid soap. First, we need to put the bananas and some water and salt, because salt causes proteins to clump together, and liquid soap because it disrupts the cell membrane. After crushing it, it will look like this. Then we need to filter it. And then after it gets gets filtered, we need to put alcohol. Because alcohol causes DNA to precipitate. After some while time, it will look like this. And the white thick structure is the DNA of the banana. The full form of DNA is deoxyribonucleic acid. DNA, the function of the DNA tells amino acid to make perfect protein shape. Thank you.
My dear teachers and students, I, Rachel Jane from class 6B is now going to perform a science experiment. So, the name of my science experiment is Super Soap Bubbles, and the apparatus we need for this experiment are 200 ml of water, 1 tablespoon of sugar, 2 tablespoons of dishwasher, a straw and a spoon. So first we need to pour the sugar into the water. Then the dishwasher and mix everything very well till everything dissolves. So now the solution has dissolved and now we need to pour some solution on the table. And spread it. Now we need the straw and blow air on the table to form the bubble. So now a bubble is formed. Sugar and soap make a tough solution. When you blow air into it, the film will stretch and form a bubble which encloses the air blown into it. The air pressure inside is slightly higher than outside, so the bubble remains round and stable. The bubble will only burst if it gets a hole or too much water gets evaporated from the solution. Thank you.
Good morning, friends. I am Ishan Bharadwaj from 6B Sulochana Devi Singhania School, and today we will be doing the hopping corn experiment. You will need corn kernels, baking soda, vinegar and plain water. As you can see in the water, baking soda and the vinegar, they all have sunk. Now let's see what happens in the baking soda and vinegar solution. We are going to put in some corn kernels, some baking soda solution, and finally some vinegar. As you can see, the bubbles are rising and popping, and the corn is going up and down. The secret to the magic dancing corn is the baking soda and vinegar chemical reaction. Baking soda and vinegar react to form carbon dioxide. The carbon dioxide bubble lifts up the corn, but as the bubbles pop, the corn falls back down. Hope you like this experiment. Thank you.
Hi, I am Parth Shinde, and today I will be showing you a science experiment on disappearing of a coin. For this, we need a coin, a glass, and some water. So, now let's start the experiment. First, we have to place the coin on the flat surface, then place the glass over the coin. We are still able to see the coin through the glass. Now let's try pouring some water. The coin has disappeared. The trick behind all this is the refraction of light. Now, what is refraction of light? The refraction of light is the bending of the light as it passes through one substance to another. In this case, the light rays travel through air and they experience little or no refraction. That's why we were still able to see the coin through the empty glass. When we poured water into the glass, the coin disappeared because when light rays travel through a substance such as water, they experience greater refraction because the molecules are closer together. Hence, we were not able to see the coin through the filled glass. I hope you like my experiment. Thank you.
Hello friends, my name is Arav Chandoli. I am from Singhania School, Standard 6, Class B. Today I am going to show you an interesting experiment of liquid smoke. It is amazing. You can try it at home, but be careful while lighting the foil. So now, let's get started. First, we need a piece of foil, 7 matchsticks, a pencil, a matchbox and a candle. Now, I will take the foil, keep the matchsticks on it, take the pencil, keep it below the matchsticks and now roll the foil. Now I have to cover the foil from the upside and remove the pencil. Now I've taken the frozen glass and I'm keeping the foil in it. Now I will take the candle and light the foil. Now to remove these and cover this. Now after I cover the glass, I have to keep it for a few seconds. Now I remove it and pour the gas which looks like a liquid. So the conclusion of my experiment is that when extreme temperatures like extreme heat and cold combine, a gas is formed which looks like a liquid and it is heavier than the air as it's cooled in the glass. Thank you.
My name is Vedika Pritishni. I am in 6B. Today I am going to do an experiment. My experiment's name is diffusion. Now first I will do the experiment. Now here I have taken 2 glasses. In the first glass there is in cold water and in second glass there is in hot water and a pinch of food color. Now in both the glasses I will put a pinch of food color. Now we can see in the cold water the color is settled down and in the warm water the color is dissolved completely. Now I will explain you why. Diffusion is the mixing of molecules due to their random motion, whether in a liquid or a gas. Molecules in warm water have more energy. They move faster than the molecules in cold water. The food coloring you add to the water is pushed up around by the water molecules. Since molecules in warm water move fast. Since molecules in warm water move around faster, the food coloring spreads out quicker in warm water than in cold water. Thank you.
Hello friends, my name is Soumit Bhide from class 6B. Today I am going to show you a live model of tabletop volcano. Volcanoes are openings in the earth's crust. They are ruptured in the crust of the earth which bring out hot lava, magma and volcanic ash when erupted. First, I have taken few newspapers, a volcano cup, a funnel, some baking soda, dishwashing liquid, red and orange food dye mixed together, 2 cups of vinegar. As you can see, I have spread the newspaper on the table. Now I will put the baking soda into the volcano cup. Now I will put the dishwashing liquid into the volcano cup. After putting the dishwashing liquid, I will put the red food color into the volcanic mixture. After putting the red food color into the mixture, I will take the vinegar, and as I put the vinegar into the volcanic mixture, see what happens. As you can see, the volcano is erupting. Now the volcano has erupted, and let's quickly understand how does it work. When the vinegar and the baking soda react, a chemical reaction takes place which produces carbon dioxide, and the carbon dioxide tries to escape in the form of bubbles. And when the carbon dioxide has escaped completely in the form of volcanic bubbles, the eruption slows down and it becomes flat and stops completely. The dishwashing liquid also helps and slows down the volcanic eruption, and it also makes it foam. Thank you.
Hello everyone, my name is Krivika Thakkar and today I am going to perform an experiment, the balloon rocket. For this experiment we would need a small straw, a sellotape, a scissors and a balloon. First I will weave the straw into a string that is tied to a hook. Then I will ask someone to hold it. I will blow up a balloon. Then with the help of some sellotape, I will stick the balloon to the straw. Then I will give it a little push and you saw the balloon went up like a rocket. This is due to the head and thrust. Thrust can be defined by the Newton's third law of motion. The third law states that every action has an opposite but equal reaction. As the balloon forces the air out in one direction, the balloon is propelled by the force in the other direction. In this manner, the balloon flies across the string like a rocket. Thank you.
Hello, my name is Aksar from class 6B. Today I will be making a water clock. Making a water clock is not very complicated. You will just need a plastic bottle, a timer and some water and a marker. Now you have to take a bottle and cut it into two halves, not equally, but the half with the bottle cap should be smaller than the other half. Now you need to mark a hole on the bottle cap. Now place the half like this and take your glass and start the timer and pour water till the half. Now after 1 minute we will mark with this marker. Now pour more water because the water is not falling very quickly. It is almost 1 minute and mark with your marker. Now it is almost 2 minutes and I will be marking again. Now it is 3 minutes and I will be marking again with the marker. Now this is the last watermark I am going to make. Now stop the timer. Now there are four marks, which means that 4 minutes have passed. Thank you. Greetings
respected teachers, and my fellow friends. I, Manasi Tamhankar, am presenting a science experiment based on the properties of air pressure. This experiment is called as a hover disk. For this experiment, you need an old CD, some glue. You can also use liquid glue, a plastic bottle lid in which you have to make a hole in the middle, and a balloon. The first step is to apply glue in the center of the CD. Then place the lid on it. Make sure it has stuck properly and leave it for 1 to 2 hours till it dries. After 1 to 2 hours, your CD will be quite steady and ready to use. Then blow your balloon. Then twist your balloon. Stretch its neck properly. And then the tip of it, like this. Then when you think that it is stretched properly, place it on the lid like this. After placing the balloon on your lid, untwist the balloon. When you leave it, it will slide and glide on its own. And when the air in the balloon is lost due to air pressure, it will stop moving. Thank you.
Hello everyone and welcome to my science experiment. Today we will talk about good and bad conductors of electricity. Here I have a circuit and some objects. If the object is a very good conductor of electricity, both of these LEDs will glow. If it is a poor conductor of electricity, none of these LEDs will glow. If it is a good conductor of electricity, one of these LEDs will glow. Let's see what happens if we take plastic. It is a poor conductor of electricity. Paper. Paper is also a poor conductor of electricity. Copper. Copper is a very good conductor of electricity as both the lights are glowing. Glass. Glass is also a poor conductor of electricity. Sugar syrup. It is also a poor conductor of electricity as none of these lights are glowing. Normal tap water. Tap water is a good conductor of electricity but not a very good conductor of electricity. Lime with water. It is a very good conductor of electricity as both of these LEDs are glowing. Salt mixed with water. This is also a very good conductor of electricity. Now why is water a good conductor of electricity? Because it has some impurities. But if you add salt to it, the impurities gain. So it will be a very good conductor of electricity. But if you take distilled water, there will be no impurities. So it will be a poor conductor of electricity. Now I hope that you can identify between good, very good and poor conductor of electricity. Thank you.
My name is Harshit Makhijani and today I am going to perform an experiment on electromagnetism. What is an electromagnet? A magnet which is made by an electric current is known as an electromagnet. An electromagnet is a temporary magnet. Why is it temporary? If the current in the coil is turned off, it will lose its magnetic power. So, it's called as a temporary magnet. To increase the power of the magnet, we should increase the number of coils in it. Now, to make an electromagnet, we first need to wind the copper wire around the iron nail at least for 20 times and try to attract these paper clips. It doesn't attract as it doesn't contain the properties of electromagnetism. Now when I pass the current through the iron nail and try to attract these paper clips, it attracts as it now contains the properties of electromagnetism. Thank you.
Hi, I'm Radhika Agarwal from 6th F. Today I'm explaining two properties of magnet. Any object that exhibits magnetic property is called a magnet. One of the property of magnet is that like poles repel and unlike poles attract to each other. To illustrate this property, I'm doing an experiment. Take two magnets. The red side of the bar magnet is the north side and the blue side is the south side. Now, as you all know that the ends of the magnet have more stronger magnetic force than the middle. Since the magnet has two poles, it is called as the magnetic dipole, which analogues with the electric dipole. Now, you see I have taken a bar magnet and a horseshoe magnet. Now, take the north side of the bar magnet near the south side of the horseshoe magnet. You'll see that they attract. Now, take the north side of the bar magnet near the north side of the horseshoe magnet. You'll see that they'll repel. This proves that unlike poles attract and like poles repel. Now, I'm doing the second property, which is that compass uses its magnetic property near a magnet. Here, I have a compass. Now, I will place it on a table and take a magnet. The compass is showing the north direction as this direction, but as I bring the magnet towards it, it's showing the wrong direction. When the south side of the magnet is shown, the compass shows the north side of it, and when the north side is shown, the compass shows the south side of it. This proves that compass uses magnetic properties near a magnet. Thank you.
Hi everyone, I am Sarah Lumde from class 6F and I am going to introduce you to my immunity chart. Now, what actually immunity is? The immunity system is made of cells, tissues and organs to protect our body against infections and also maintain our overall health. The human body has an excellent environment for germs such as bacteria, fungi, viruses and parasites to flourish. The immunity system works to limit these microbes from attacking the body. Now, I would like to tell you some facts about it. Stress can affect the way your immune system works. Positive emotions and a healthy lifestyle may boost your immunity. Your immunity system can attack itself. Cycling may help you increase your immunity. Now, do you know one thing? A child is always happy and smiling. Therefore, it has a better and good immunity system. Now, how to boost your immunity? First, getting enough sleep. Kids should take at least 8 to 10 hours of sleep, while adults should have 7 to 8 hours of it. Healthy food. Make sure to intake all the nutrients in a sufficient and adequate amount. Meditation and exercise. Meditation keeps us mentally fit and helps us control our stress, while exercise can keep you physically fit. Water. We all must take at least 2 liters of water per day. Thank you.
Respected teacher, I am Venu Murli from 6K. Today, my aim is to demonstrate magnetic levitation. My apparatus consists of a stick fixed to a sturdy base and 2 rectangular shaped magnets with a hole in between so that they can slide along the stick. First, I have to check that which 2 surfaces of the magnets attract each other. Then, I have to drop the 2 magnets in such a way that their attracting surfaces face each other. Now, you can see that the 2 magnets are in contact with each other. For the second part of the experiment, I have to remove the second magnet, turn it around and drop it such that the 2 surfaces repel each other. Now, you can see that the second magnet did not fall to the bottom, but instead it is suspended in mid-air, resisting gravity. This is magnetic levitation, where an object is suspended in mid-air and its only support is its magnetic field. Magnetic levitation comes in use where friction leads to loss of efficiency. The best examples are maglev trains, where there are 2 sets of magnets. One set of magnets pushes the train above the tracks and the other sets of magnets pushes the train forward, and hence the friction is reduced and the speed is increased. Also, maglev technology comes in use in maglev windmills, where the rotor is levitated, hence the friction is less and the windmill fans move faster. Magnetic levitation has much more applications. Thank you.
I, Nehal Nitya of Standard 6K, is going to show you an experiment based on the principle of buoyancy. Let me tell you first, what is buoyancy? Buoyancy is the force that causes objects to float. Now, as you can see, there are two oranges in the bowl, one with peel and other without peel. Technically, the orange with peel should have more weight, and hence we will put it inside the water. It should sink. Let's observe what will happen now. Oh, the orange with the peel is floating. Let's see what will happen to the orange without the peel. It sinks. The conclusion we can draw is the orange with the peel floats because the peel is porous and filled with tiny air pockets. These pockets of air help increase the buoyancy of the orange. Therefore, the orange without the peel is denser than the water and it sinks. Thank you.
Hello guys, this is Riya Pradhan from class 6th A, and today I will be showing you the experiment of color glass. Let's get started. What we need is a plate, milk, a earbud, 2 pipettes, soap and any colors you want. So now we will take a pipette and take any color you want with the help of the pipette, and then we will drop it in the milk. You can take another color. Now we will take the cotton bud and the soap, and right in the middle we will put it. Can you see this? We can do it again. Wow, it's so amazing, isn't it? Now, what did we observe? We observed that when I took the soap and put it in the milk, all the colors started bursting around. Why did this happen? The secret of bursting colors is the chemistry of the tiny drop of soap. It weakens the chemical bonds that hold the protein and fats in the milk. The soap's water-loving end dissolves in the water, and the soap's water-fearing end attaches to a fat globule in the milk. The molecules of fat roll and twist in all directions as the soap molecules race around to join up the fat molecules. As the soap becomes evenly mixed in the milk, the action slows down and eventually stops. Thank you.
Dear respected teachers, hope you are keeping well. I am Pavni Tunga, studying in 6th. Today we are going to perform a fun chemistry experiment related to density of solid and liquid. So why do objects that are of same size have different weights? That's because of density. An object's density is determined by comparing its mass with its weight. For example, if you compare a rock and a cock, which is heavier? The rock, because it has more mass and also due to the atomic structure of the element, compound and molecules that make it up. Experiment time. For the experiment, we will be needing stone, key, coin, screw, a plastic ball, wax, a piece of wood and leaf. Now you need to arrange this in a tub of water. Now let's observe. And here we conclude. Objects which are heavier than water sink and objects which are lighter than water float. Eureka, Eureka!
Thank you, Archimedes, the genius Greek mathematician who invented density and gave us a method of thinking that we can invent many more things. I hope you enjoyed my video. Thank you. Stay safe, stay strong.
Respected Principal Mrs. Revati Srinivasan, Vice Principals, Heads, Coordinators, Grandparents, Parents and dear students. I, Megha Divanji, on behalf of Junior Section would like to thank you all for giving us this rare opportunity to show our scientific attitude and help students to learn through the online platform. The tremendous amount of efforts put in Anweshan shows that our loving teachers have truly dedicated themselves in helping us. Without their help, this program wouldn't have been a success. This program has helped us realize what was once told by Robert A. Heinlein. Everything is theoretically impossible until it is done. So our young scientists have proved this true by performing the experiments and showing various new concepts. It's through curiosity and looking at opportunity in new ways that we have always mapped our path. Let this path guide us to a new world of exploration. Once again, thank you to one and all. Dear Principal Ma'am, we are looking forward for such new and exciting ventures in the near future. Thank you and have a safe stay.